Ladies and gentlemen, I greet you again today. Our subject or course is accounting for managers. In this discussion, we'll be looking at investment appraisal. By investment appraisal, we are saying as managers, you are expected at some point during the course of discharging your mandate to analyze investments that your organization is making. Essentially, investment appraisal is all about determining whether the organization is performing well, its assets are performing well, since investments would have been made in assets. Specifically today, I'll be looking at the methods or the techniques that are used when managers are trying to determine or to ascertain the performance of their assets, how much money they are generating. This is an exercise that is done before a decision is made whether to invest in a particular asset or not. So we've got various methods that are used, but specifically in our course we are required to look at the payback period. So we shall be looking at the payback period technique or model. Then we'll also look at the discounted payback model. Then eventually we'll look at the net present value model. Well, I'll begin by looking at the payback period. The payback period simply means when we invest in a project, we would like to know the length of time, be it in months, be it in years, it will take for the project to be able to recover the capital that was invested into it. So, as you can read from the slide, the payback period is the length of time that it takes for a project to recover its initial cost out of the cash receipts that particular project is generating. So, the formula for payback period is as shown on the slide. The investment required, which is the initial amount injected into the project, divided by the net annual cash flow. One thing should come out clear here. When we talk of net annual cash flow, we are saying the actual money that remains for the business after taking away or out all the expenses associated or that were incurred in the process of generating that revenue. That's what we mean by net annual cash flow. Well, I've got an example here. We are given project A and project B in that example that you can see on the slide. So the project A requires an initial capital outlay or an initial investment of $15,000, whereas project B requires an initial capital injection of $12,000. Now, the business or the managers would want to know, out of those two projects, which of the projects is better, which of them is more profitable. Now, we said we are going to be using the payback period model, also known as the payback period technique, to determine which of the two is a better investment. Well, like you can see, when you look at those cash flows, okay, I want us to see how we calculate them. First of all, the initial investment, it is money that is going outside the organization. So in our next slide, as you will see, I would have put this 15,000 as a negative figure and the 12,000 as a negative figure. Well, where I say cash flow year one, this is a net cash flow that we are receiving in the organization at the end of year one, the total. So in this case, we assume at the end of year one, we would have received from this project A total net cash inflow of 5,000. In year two, 5,000, 5,000, so forth. So I've just tried to simplify this example. Okay, let us see how we go about calculating these figures. Okay, we have got on this slide, you see my figure here, the first one, let me highlight it. This is for project A. That figure is negative. And I've indicated here year 0. This year 0 represents the investment that we need to do before the project starts generating cash inflows. Now, so we must invest a total of 15,000. It's negative because it's money that is going out of the business. At the end of the year, the first year, that is year 1, the project has managed to bring back 5,000. In other words, we have receipted net cash inflows in the sum of $5,000 at the end of year 1. So we have got the first column, our years, year 0, 1, 2, 3, 4, 5. The fifth one is the last year, the lifespan. It represents the lifespan of the project. Both of this project that we'll be looking at are 5-year projects. At the end of the year 5, it means we either dispose of the assets that we would have bought in respect of this project. Well, now, we need to come up with the third column, cumulative cash flows. The CF stands for cash flows. Now, when we say we want to determine the payback period, we want to determine the year in which the project would have recovered everything or every amount that was invested into it. We invested 15,000. So by cumulative, what I'm simply saying, I'm taking the cash flow in the second column, right? I put this one direct here. Then I'm saying here it's negative 15,000 because I took it exactly as it is to this column. Then I will add to this the cash flow that will generate in year 1, which is 5,000. If we say minus 15,000 plus 5,000, we will get negative 10,000. It's reducing because the other one is a plus. Well, having arrived at this negative 10,000, I add again the cash inflow that we're getting in year 2. That will leave us with a cumulative cash flow of negative 5,000. Well, I'll add again the cash flow that we receive in year 3, and I'll end up with 0, a cumulative cash flow of 0. If I were to go on and on, I would add again the cash flow for the next year, which is year 4, and I'll end up with a cumulative cash flow of 5,000. You will see that our cash flows now are in the region of positive figures. If I'm to add the next year cash flow, it's now going up, it will be 10,000. Now, the year of interest here is the year where the cumulative cash flow is 0. Now, we find that this cash flow is, cumulative cash flow is 0 in year 3. So this third year, I've put a circle there, I hope you can see it. That's where our payback period is. Now, in the case of this problem for project A, our cumulative cash flow of 0 is found in year 3. Therefore, our payback period is 3 years. Well, what does that mean? Let us say the organization has got a policy that when it's appraising its projects on the basis of the payback period, if it sees a project that has got, say, a payback period of 2 years, it must accept. In other words, the organization will be having a policy that says all investments or all projects that we invest in that are able to pay back the amount invested into them within a period of 2 years or less, they are acceptable. In this case, the payback period, we find that it's 3 years. But if the policy says we only accept those ones that have got a payback period of 2 years, it means we are supposed to reject this project because it does not satisfy or meet the policy of the company, which says only accept projects that are less than 2 years, 2 years or less. So that's one. I want us now to look at project B. So the payback period for project A we now see is 3 years, simple and straightforward. Let's look at the next one, which is a bit complex, slightly challenging than the first project. Well, okay. You'll see from the cash flows on the slide, or the ones that I'm working on here. If you look, again, we did the same. The first column, I started from year 0. The second column, that's the cash flows, beginning with the first one, which is minus 12, which is a negative. And as with the previous, with project A, the cash flows, I put them at 5,000 again throughout. Well, the cumulative cash flows is minus 12,000 in year 0. That is the initial investment or initial capital outlay. Then, at the end of year 1, we have got this, which is a positive 5,000. Now, our cumulative cash flow, remember, first we just took it this side. And now we say minus 12,000 plus 5,000 that we get at the end of year 1. Then we have a negative 7,000. What does that mean? It means now at the end of year 1, the project is still required to pay back a total of 7,000. That's the amount outstanding. Okay, let's go to year 2. We add again the cash inflow, which is positive, that we get in year 2. Then what does that give us? It leaves us with a negative 2,000. What does that mean? It means the project is yet to pay us the remaining 2,000 for it to fully recover the 12,000 that was invested in it initially. Well, let's go on. We add again the cash flow that we receive in year 3, and it will leave us with a positive cumulative cash flow of 3,000. Well, we can go on and on. You see it will increase. We do that, and there. Now, we have said our payback period is a period where the organization or the project would have paid itself all the money that was invested in it. Now, here is a challenge. If you look in this cumulative column this time around, we don't have a 0. The 0 is missing. In the previous one, we had a 0, as you can see on the slide. But in this one, we don't have a 0. But let's do something here. We know very well, if we've got, in year 2, we've got a cumulative cash flow of minus 2, and in year 3, we've got a cumulative cash flow of 3,000 positive. The other one is positive, this one is negative. It means between year 2 and year 3, that's where we have got our what? Our 0. We need to get to that point now. How do we do it? Okay. Here is what we will do. Okay. Out of our cash flows, let me do this. Okay. At the end of year 2, we have got negative 2. This negative 2,000 is the amount that we still need to recover. Now, it means this 2,000 is going to be recovered in year 3. Right. Year 3, let me do this calculation. In year 3, our cash flow is supposed to be 3,000. But at the end of year 2, we are only left with 2,000. We only need 2,000 to recover the amount invested. So I'll put this amount yet to be recovered as the numerator, and the cash flow in year 3 is my denominator. All right? Having done this, I must write down here already. I know that the full years that are needed are 2 years. If you look on the slide there, the full years that we need are what? Are 2 years. Now, I'll write my 2 years down there. Okay. 2 years, at the end of year 2, we would have recovered some amount, but we're still yet to recover 2,000. This 2,000 is what I put as my numerator, and it's going to be recovered in year 3 in the cash flow that is coming in year 3. That's why I put my 3,000. So, I don't need a full year, because a full year that will take me to the end of third year of year 3 will bring in 3,000. But I just need a fraction of that particular year. And that fraction is proportional to 2,000 over 3,000. Now, a fraction of a year should be given in months. So I shall multiply this one by 12 months, because we've got 12 months in a year. Well, let's do the calculations. This cancels. This is 2,000 of a year. Sorry, 2/3 of a year. 2/3 of a year, we know it's simply 3 into 12. 3 into 3, 1. 3 into 12 goes 4 times. 4 times 2, it's equals to 8 months. Right. So, our payback period, I'll take this to add it to the 2 years. Our payback period becomes 2 years, 8 months. So this project requires 2 years, 8 months to pay back the money that was invested in it. This is what I highlighted here. Project B. We look at the number of years needed, it's 2 years, then plus 2,000, which is the negative amount that we are yet to receive, divided by 3,000 times 12 months. It gives us 7.99, which I rounded up to 2 years and 8 months. Now, what does this mean? Let's go back to our example. The first project, remember, we had a payback period of, that's project A. I'll write it here. Project A. Its payback period was 3 solid years. Then project B, its return or payback period was 2 years, 8 months. Now, when you look at these two, project A is taking longer to recover the money invested in it. Project B takes a lesser time to recover the money invested in it. Therefore, if we are to compare these two, which one is better? This one obviously is what? Is better, because it takes a shorter time to recover the money invested in it. It's like when you lend money to A and you lend money to B. But B takes 2 days and some hours, or a shorter period to pay you than person A. Therefore, you would rather give your money to the person who takes a shorter time to return the money back to you, because it means there is less risk in that regard. Well, that is about a payback period. Now, I want us to go and look at the next other method that we use to do our calculation, which we call the discounted payback period. Now, I must explain something why we ended up with the discounted payback period. Right. What tends to happen is when we are using the payback period, we just took the cash flows raw as they were. But in practice, or in reality, cash flows are affected by inflation. So we say the money that we receive today is different from the money that we will receive after 1 year. when you look at this slide, the 5,000 that we receive in year 5 doesn't have the same value as the 5,000 that we receive after 1 year. Why? Because the 5,000 received after 5 years would have been eroded by inflation. It would have lost value as a result of inflation. Now, this is a concept that I'm quite positive you are familiar with, the concept of time value of money, which simply says money loses value with the passage in time. Well, so for us to be more realistic, to make sure that we are measuring the correct value when we are determining the worth of a project, we need to take into account the time value of money. That is, we must factor in inflation. Well, let's go back to project A. With project A, I'm just assuming that we have an inflation in the country of 7%. That inflation of 7% is what we're trying to factor in our calculations of a discounted payback period. We are reducing the value by discounting. If you go to the shop and you buy and you get a discount, what you're simply doing is they are reducing the price of the commodity. So here, the money that we're getting in year 1, year 2, year 3, it's being affected by inflation, so we must reduce its purchasing power or its value. And we do so by taking into account the inflation reigning in the country. Here I assumed that we are experiencing an inflation of 7% per annum. Now, that is the figure now that we will use to discount our cash flows. It may be a figure representing inflation plus some risks associated with lending money to individuals. So when you go and borrow money from the bank, they will charge you interest. Currently, I would like to believe if you go and borrow money in Namibia to any of these financial institutions, you may be charged an interest rate in the region of 12 to 13%, depending on where you get it. That 12 to 13% is your cost of capital, the cost of borrowing that money. And it is the same that is put by the money lenders in order to represent the effect of inflation and risks associated with lending money to people. Well, here I just took a smaller number, 7%. What we need to do under the circumstances is we are going to discount. Now, you see the letters PVIF here. These letters, they simply stand for present value interest factor. Present value interest factor. Present value interest factor, it's something that we get using the formula present value interest factor is obtained at using the formula 1 plus r to the power negative n. Wow. Whereas this r stands for the interest that we are using there in the discount factor, in this case 7%. This is the interest rate or discount. Discount rate. And this one is just a 1. N is the period. The period, in this case, it's being represented by a year. At the end of year 1, we put 1 there. If it is end of year 4, our N will be 4. That's what it means. Okay. Now, we do these calculations manually, but more often than not, we are having what we call tables. These tables are obtained in your accounting textbooks. I will just show you how these tables look like. Let me try to zoom this further. Right. All right, I hope you are able to see. If you look at this table, this is what we call a present value interest factor table. The present value interest factor table has got this column, period. PD stands for period. And in that period, you would find that we've got 1, 2, 3, 4. These numbers going down here are representing the years in our example. And the first numbers in percentage there, they are representing the discount factor or the interest rates that we factor in. In our example, we are using 7%. So we are interested in this 7%, sorry. We are interested in the 7%. I mixed up my things here, my apologies. Just a minute. This one, 1, 2, 3, 4. Okay, this is what I want. I'm looking for 7%. Perhaps I must zoom down. Okay, I hope you're able to see. 7% is somewhere here. This is where my 7% is. So I'm focusing on this one. Let me highlight it. This is the column that I'm focusing on. Now, when you look at the figures, I want you to be looking at the figures on the slide as well. In year 1, it means year 1. At the end of year 1, I've got a figure here. The figure that I have here, it's 0.735. If you go again at the end of year 1 on the slide, you see 0.935. That is the present value interest factor that we will be using. At the end of year 5, I've got 0.713. You see it's corresponding there. So these tables are already made for you. You just use them. So what we do, we'll just take them for year 1, year 2, year 3, up to year 5. We slot them there. If our discount rate was 9%, we would have used this column. So they go on and on, right? You'd find these ones are adding up to 9. Then I've got some that are continuing here from 11 going onwards, on and on. Well, having said that, let's look at our slide. Now, here is what I have done. I have multiplied these two columns. The cash flow, I'm multiplying it by this present value interest factor. One thing, in year 0, there is no passage of time, so we are not affected by inflation. So this figure will not be affected. That's why I put a present value interest factor of 1. It remains 1 there. Therefore, from year 1 to these are the figures. So what we are simply doing now is we are multiplying what is in the cash flows columns with the present value interest factor in order to get what we call the discounted cash flows in the third column. Now, it's this multiplied by this, we get 15,000. I multiply this by this, I get that. That's what I'm only doing. There we are. So that's how we got those figures, the cumulative figures. Now, having done that, when we are dealing now with the discounted cash flows, here is what I need us to do. When we are dealing now with our discounted cash flows, right, we are going to look at these figures. So the figures that are to the far right, the figures that are to the far right in this column, the last column, discounted cash flows, are the ones I want you to forget for the time being. Forget this figure that I put here. Okay, forget that figure and let's look at these figures, the discounted cash flows. What we'll do now, and here I put net present value. Let's put it discounted payback. I shall use the same form later on. So When we are now calculating our discounted payback period, we are now going to look at these figures. These are the figures that we are going to use. You can see these figures on the slide, the third column, is it the fourth column there, or the second column from the right, where we've got 4,673, and so forth, so forth. That is the discounted. Then the cumulative figure is at that far end. Now, I want you to pay attention at what we are looking at on the screen. We have got in year 3, that is if we are looking at the figures on the screen, we have got in year 3 a cumulative cash flow of 1,878, which is a negative. Then we have got in year 4, at the end of year 4, a positive cumulative frequency of 1,936. Like we have said earlier on, it is between year 3 and year 4 that we have got our cumulative cash flow of 0. Now, it means at the end of the third year, at the end of year 3, we have got, let me do that. At the end of year 3, which means we have only 1,878 to recover. So our payback period would know it's already 3 years. But at the end of the third year, we are yet to get 1,878. How do we get that? Like we did earlier on, we are going to say the amount to be recovered becomes our numerator, 1,878. Then we divide by the cash flow that we are supposed to receive in year 4, which is 1,936. That figure, we multiply it by 12 months, right? Why are we doing that? Because we are saying at the end of the third year, the full 3 years are needed. But we still need to recover 1,878. Now, this 1,878 is going to be recovered during the course of year 4. But year 4 is bringing in more money than we need to recover. So we don't need the whole of year 4. It's just going to be a fraction of a year. And a fraction of a year is given in months. That's why we're multiplying it in months like that. Now, let me do some simple calculation here with you. Remember, we are there. So we are going to simply say 1878. We divide that by 1936. Right. We get a number. This part alone, leave the 3 on the side for the time being. This will give us 0.9700. Let's ignore the zeros. Then we shall multiply this by the 12 to get the months. Our answer should be in months here, right? Let me do that. Multiplied by 12. What do I get? I'll get a figure of 11.64. So our payback period is 3 years, 11 months. But remember, we had a figure of 11.64. So far, I've brought down the 11 here. How about this? It means I still have a 0.64 of a month. Okay? Because the 11 months, I've brought it down here. These are full months. So we need to account for the what? For this 0.64. Now, a fraction of a month is given in days. So how do I get it? I'll go and say 0.64 multiplied by number of months in a month. We just use an average of 30. So I'll say multiply by 30, and what I get here should be days, because this is 30 days, huh? 30 days. Therefore, right, if I say 0.64 multiplied by 30, I'll get 19.2, right? Which means it's 19.2 days. Now, the 0.2 is in hours, so I can just ignore it. Remember, in accounting, we normally follow the concept of materiality. When something is not of significance, it's immaterial, we leave it out. Now, let's put things together here. What do we have? The discounted payback period, which I'll call discounted PPB, payback period. For our project A, right? Project A, it will be, remember we take the 3 years down, 3 years, right? How many months? 11 months, okay, and 19 days. That becomes our answer to that. That is our discounted payback period. Now, we go back to the organization. If the concept or the policy of the organization is that we should accept projects that have got a payback period of 2 years and not more, we would reject that, because this discounted payback period is more than what the policy requires us to follow. But if the policy of the organization says we accept all projects that have got a discounted payback period of 4 years, up to 4 years, so which means anything less than 4 we accept, 4 and less we accept. This is 3 years, which is less than 4 years. We would have accepted this project on the basis of payback period. Now, I want us to look at the present value, the calculation of the present value. I'll go back to that slide that we looked at earlier on. The way we calculate the discounted payback period is almost the same way we calculate our right. It's the same way we calculate our. I'll use this one. This one was for the payback period. Now it's less debt than this one. Okay, let me use this one. Still okay. The one where we had said I had mixed up my papers here. But here's what we're gonna do now. We want to calculate the net present value. The net present value, it's another model or technique that accountants or finance managers use to determine the worth of a project. It's simple. The same concept that we used when we were calculating our discounted payback period. The only difference is here we're not interested in the payback period, but we want to say after having done discounted the cash flows, you remember how we got these figures, and these figures are the raw data, the original data. The discounting factor is the cost of capital. You'll be given this, and you do your discounting by multiplying this column, the raw data, the real cash flows, by the present value interest factor, then you get the discounted cash flow. The same way we did when we were calculating the payback period, discounted payback period. But this time around, we don't need to come up with the cumulative frequency for our discounted cash flows. Once we have got our discounted cash flows, we add them, taking note that the first cash flow is a negative. So we are simply saying negative 15,000 plus 4,673 plus 4,306 up to the last one. Then we find the net. In this case, if you are to add these figures from year up to year, if we add them, what do we get? We'll get this figure of 5,501, right? It's in dollars, and this is our net present value, right? Net present value, what does it mean? It is simply saying when we look at a project, we look at all its cash flows, the cash flows, net cash flows that it will generate in the future, both cash outflows and inflows, we net them together. If we remain with a figure that is positive, that is what we call a net present value. The net present value, it simply says the money that we are receiving in year 5, we have discounted for the effect of inflation, and we bring it now together to today, in today's terms, we get the present value, the net of the present value of the future cash flows after having discounted them at the discount rate that is equal to the cost of capital, or that takes into account the element of inflation. Well, that takes us to the end of this discussion. I hope you find it helpful. Until next time, ciao, ciao.